Okay, let's start with number 4. And they just want us to add these two matrices together. So now you may never even seen a matrix before, aside from watching the intro video. And if you didn't watch that, maybe you have never ever seen a matrix before. But if I asked you to add these two together, and I've done this many times with many students, and I don't think I've ever gotten an incorrect answer, because it's a pretty straightforward thing that you would just kind of assume you would do, and you would be right to say that I'll just take 5 and add -8. Just the things that are in the same position in these two matrices, I'll put them together. So 5 plus -8 is -3, and 2 plus 10 is 12, and -1 plus -6 is -7, and 8 plus 3 is 11. And that's it. You've added two matrices together. Let's try number 6. They want us to subtract two matrices. Got 4, -5, 8, 1, minus 2, -1. Okay. Addition and subtraction, very similar things. You would think that you'd do the same kind of thing here. You would just subtract the things that are in the same position. The problem is we don't have, if you're supposed to do 4 minus 2, then what are you supposed to do with -5? There's nothing there to do with -5. And the lesson here is if they're different dimensions, you can't add them together, because matrix addition depends on you being able to put the things in the same positions in each of the matrices together, putting 5 with -8 and 2 with 10. But it doesn't match up. So the dimensions are different. You can't equal anything. We can't do this. You'd say mismatched dimensions. Oh. And now I'm going to forget how to spell dimensions. With an S. Alright. So, let's try another one. The next thing here is called scalar multiplication. A scalar is just a number. I want to scale it up or scale it down. Right? So I want to take this matrix, -1, 4, 3, -6, and I want to scale it up. I'm going to make it bigger by a factor of 2. So this is something that I've also posed to many students, and I don't know that I've ever gotten an incorrect response. It just seems like if you're going to multiply this by 2, you'd make everything twice as big, and that's right. So 2 times -1 is -2, 2 times 4 is 8, 2 times 3 is 6, 2 times -6 is -12. And there you go. And if that's not what you thought you should do, now you know. You just multiply everything in here by this scalar. We call this the scalar. Multiply everything by the scalar, and there you go. You've multiplied a matrix by a scalar. Whether that scalar is a fraction or a negative, that still holds. For number 18, I'm sorry, we're going to do 17, and then 18. And for both of them, this is going to be what matrix A is, and this is matrix B. And for 17, they want us to take matrix B and subtract matrix A. So we just need to make the appropriate substitutions. So here's B. And we want to subtract A. Okay, you want to be careful with matrix subtraction. If necessary, you could distribute this negative to everything, and then it'll become addition of the negative. That would work. The thing you need to be careful of is that everything gets subtracted. The 5 gets subtracted. The -4 gets subtracted, which means 4 gets added. That's what you want to be careful of. So 18 minus 5 is 13. -12 minus a -4, that would be the same as -12 plus 4, is going to be -8. -6 minus 3 is -9. And 0 minus a -1, or 0 plus 1, is 1. So there's b minus a. Now 18. 4 times a minus b. Okay, so I'm going to do something a little crazy. I'm going to go to write down our first matrix here. But as I transfer this to there, I'm just going to multiply each of them by 4. So 5 times 4, which is what we would do if we're multiplying matrix A by 4. 5 times 4 is 20. Negative 4 times 4 is negative 16. 3 times 4 is 12. And negative 1 times 4 is negative 4. Okay, so here we have 4 times A minus B, which is 18, negative 12, negative 6, and 0. Okay, be careful, especially when you do minus and negative. Make sure you do that correctly. So 20 minus 18, that'll give us 2. Negative 16 minus negative 12, that's negative 16 plus 12. That'll be a negative 4. 12 minus a negative 6, that's 12 plus 6, that's 18. And negative 4 minus 0 is negative 4. All right, there we go. Nothing too scary. Let's do 24. And number 24 just helps us to further understand the equality of matrices. If two matrices are going to be equal to each other, then every position needs to be exactly the same, meaning that they have to be the same dimension and everything has to match up. So like negative 1 and negative 1, they're the same. They have to be. 5 and 5, they're the same. Well, now we have 3x and negative 18. We don't know, this needs to be negative 18, right? So what would x have to be to make negative 18? We could just say 3x needs to be equal to negative 18. Solve for x, divide by 3 on both sides, and we get x is negative 6. Okay, that's what x would have to be. Also, 2y and negative 4 have to be the same. So 2y has to be equal to negative 4, so y would have to be negative 2. So there you go. Now for 26, slightly more of a challenge here. Just a little more thinking that needs to happen. 2 times this matrix Okay, so there it is, all written out. Now, the only thing we know about equality and matrices is the equality of two matrices. Now, we don't have that. We need to have one matrix on this side and one matrix on that side. So somehow we need to put these together so that we have one matrix. Now, order of operations, we should still follow it, right? We're going to multiply this before we subtract this. So we'll multiply 2 times this matrix, which will give us 16, negative 2x, 10, and 12. Then we're going to subtract this matrix here. Let's go ahead and do that. We'll not write this again until the very end here. So 16 minus 3 would be 13. Negative 2 minus a negative 9, that's negative 2 plus 9, or negative 2x plus 9. Okay. 10 minus 10, that'd be 0. And 12 minus a negative 4y, that should be a negative there. 10 minus a negative 4y, that's the same as 10 plus 4y. Right? And that the combination of those two matrices needs to be equal to this, so we'll write that. It needs to be equal to 13, 4, 0, and 16. We're on the right path because we see 13 and 13 are the same, 0 and 0 are the same, they need to be the same. But then also this part right here needs to be equal to this. So negative 2x plus 9 needs to be equal to 4. And this guy here needs to be equal to that there. So 10x plus 4y needs to be equal to 16. So let's solve each of these. Negative 2x is equal to negative 5 if we subtract 9 on both sides, and x is equal to positive 5 halves. And over here in red, 10x is, why do I have 10x? I don't know why I have 10x. It's not 10x. It's just the number 10. So 10 plus 4y equals 16. So 4y equals 6, and y equals 3 halves if we divide both sides by 4 and simplify the fraction. So now we solve for x and we solve for y. Okay, and that'll be everything. Just some fairly simplistic, basic operations of matrices. Thanks for watching.